Hello everyone, welcome to the first class of limits. Now, limits is a chapter which many people find it difficult, but when you understand it properly, you will find it's very easy. And it's very important for mains and advanced both point of view because in advance, around two questions, one or two questions are directly asked from limits, and it will be used in continuity and differentiability also. And from there also one or two questions are asked. So directly it can impact around 3 to 4 questions in JEE Advanced, and in maze also 2 to 3 questions will always be based upon limits. And it will not be very difficult also if you understand properly. So before you start the class, just make few points here. First, you have to make notes. So whenever you just like you will see the concept. After you understand it, pause the video and make notes properly. Don't have to write everything, but just make like short notes. There's a kind of a scientific reason behind this. When you write the things with your own hand, you understand it better. So don't think that I'll take screenshot or no, I have understood, now I'll be fine. No, it's always advisable to make short notes because that will strengthen your concepts. Second, whenever you come across an example, you stop the video and then try it first and then see the solution and see if you get it right or not. Do not jump to solution directly. If you do that, you will not be able to build your problem solving skills. And third point, if you have any doubt in any of the solution I'll give, so those students who are in my class, they can just ask me in the class next day or whenever they get time. Those who are not in my class, you can just post a comment and I'll try to help you with that. Okay, guys, I hope you get these points. Now let's start. First of all, just basic introduction, what exactly it is limits and what we are doing here. See, first example we have say f of x is equal to x plus 2, limit x tend to 3, f of x we have to find out. So limit x tend to 3, f of x is 5. How do we get that? Just put x equal to 3 here. How does it work out? See, basically what we are finding in limit. So this is the graph of y is equal to x plus 2. This is the point you can see where x is 3 and y value is 5. So when you do limit x tend to 3 f of x, we see that when x is approaching 3, when x is close to 3, what is the approximate value of f of x? When x is close to 3, limit x tend to 3 means x is near to 3. It does not say x is exactly 3. So say it's x is near to 3. So when x is near to 3, what is the approximate value or where the value of fx is approaching? In this particular case, we can say when x is near to 3 means it's not like 3.1 or 3.2. There'll be very large difference. Near to 3 means like 3.00001, like very infinitely small difference. So when x is near to 3, we'll say value of fx is near to 5, or you can say value of fx is approaching 5. So if you approach x to 3 from the left side, you see value is approaching 5. If you approach x to, like if x approaches 3 from right side, the value is approaching 5 to the right side. So no matter from where you approach 3, the value of function is approaching 5. So this is kind of a basic idea what we are doing in limits. We try to see where is the value of function approaching at that point. Now, it might sound very silly for this problem that we can literally see here, if you put x as 3, we get 5. What is the point of discussing this thing also? See, this will be very easy when the like graph is a continuous function, like you see here. But it will kind of get messy when the function will not be continuous, or there will be some other cases also where the particular point will not be in the domain. So what we'll do is we'll try to figure out the values next to that. Where is the value of the function at the point which is very close to that. Okay, you will get all those ideas when we discuss more problems. So basically, just kind of remember for now, in the limit, we are trying to figure out where is the value of function approaching when x approaches that point. See, with the help of next example, see f of x equal to fractional part of x. Now you see the function is a discontinuous function. Now, discontinuous continuous function, you may not have the idea right now. We just see the function breaks. Uh, all of you must remember the function fractional part x graph. So the value between 0 to 1 goes like this, then it drops to 0 again, then goes like this, again drops to 0, again goes like this. So periodic function with period 1. If you don't know this thing, you'll have to go through your foundation where we discuss greatest integer and fractional part. You can look into that. Now, say they ask me to find out limit x tend to 1.5 f of x. Limit x tend to 1.5 f of x. So you can see here, if x tends to 1.5, the value of function will be approximately 0.5. So we can easily say when x approaches 1.5, the value of function approaches 0.5. Pretty easy here. But if we say limit x tend to 1, if we say limit x tend to 1, now there it's not that easy because you see function breaks at 1. So here it will matter. Do we approach 1 from left side or do we approach 1 from right side? So for that we have this sign. What is this thing? If I say 1 negative means slightly less than 1. Or we can say we approach 1 from the left side. If it is 1 positive means slightly more than 1. It means we approach 1 from the right side. So now if you see this graph here, if x is slightly less than 1, we just say 0.99999. If you put the value here, you get the value to be like 0.99999. So can I say be like almost 1? That means if you approach 1 from the left side, the value is approaching 1. It's not exactly 1, it's approaching 1, like almost 1, but not equal to. And if you approach 1 from the right side, then the value of function is approaching 0. So this is where you see the difference here now. Same function, same point, but if you approach from left side, you reach 1. If you approach from right side, you get 0. So this is the basic idea of limits. This is one of the aspect where we use it to those function which breaks. But more importantly, it will have significance for those function where some particular point will not be in the domain of the function. So we'll use limits to find the value in the neighborhood of that, like on those points which are near to that. We'll see that later. For now, just a few more points here. Right hand limit, like what I told you here, we approach from left side or right side. We have terms for that also to describe them. One is right hand limit, because use short form RHL, and other is left hand limit. We use the term LHL. So right hand limit, as the name suggests, we approach from right side. When we approach from right side, that means it will be slightly more. So if you're approaching A, if I say right hand limit, we'll say it is x tends to A positive. A positive means slightly more than A, so we're approaching from right side. So limit x tend to f of x will mean RHL of fx at x equal to A. And some people like use this method also. They put x as A plus h, slightly more, so we put x as A plus h. So we'll say limit h tends to 0. So if x is A plus h, and if x tend to A positive, means h will tend to 0 then. So f of x will become f of A plus h. H will be like slightly positive number. Now again, this is just for understanding. We hardly use this thing in the problems. So in some NCRT or somewhere in the boards, you may have to use this thing. But for mains advanced, we hardly use this thing. And for left hand limit, we'll use limit x tend to a negative. A negative means slightly less than a. So we approach a from left side. So limit x tend to f of x means LHL of fx at x equal to a. Here we put x as a minus h, and again h will be slightly positive because we are subtracting from a. So we see this as limit h tend to f of a minus h. Now, what is the meaning of limit exists? Limit we say exists only if LHL is equal to RHL and they both have finite value. That means if you approach to the same finite number from left and right side, then only we say limit exists. This will have importance in the next chapter when we do continuity differentiability. There we'll use this thing, limit exists. So when we approach same value from left and right, and that value has to be finite also, then we say limit exists. Okay guys, so this is the introduction of limits. Next we have here indeterminate forms. So this is the most important point. Where is the application of limits? It is for indeterminate forms. Now what are indeterminate forms? See, there are 7 indeterminate forms: 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 1 power infinity, 0 power 0, infinity power 0. So first of all, 0 by 0. Now 0 by 0 is indeterminate form. What is the meaning of indeterminate? Its value cannot be determined. So for example, if it is 0 by 0, if I take it equal to 1, and if you cross multiply, it will satisfy. So someone might say 0 by 0 can be 1. But if I take 0 by 0 as 2, we cross multiply, and that will also exist. That means 0 by 0 could be 1 also, 2 also, 3 also, any number. That means its value cannot be determined. So this is an indeterminate form. Now, infinity by infinity, see, we know 1 by infinity we can say is 0. So this infinity we can write as 1 by 0. Next infinity we can also write as 1 by 0. So basically it's nothing but 0 by 0 form. Like, just to remember, how do we remember these things? So see here, 0 by 0 only, this thing, and the third thing also. Here you have 0 into infinity, which you can write as 1 by 0. So this is also 0 by 0. So basically all three are just 0 by 0 only. Next, infinity minus infinity. Now, infinity minus infinity, it's not like you will cancel out and say it is 0. No, they are not numbers that you can cancel out. See, some infinities are greater than other infinities. This might blow your mind, but this is true. So infinity minus a very large number minus another large number does not mean 0. It could be a finite number also. You will see in the problems. Next, 1 power infinity. How do we say its indeterminate form? Let us say y is equal to 1 power infinity and take log both sides. So get log y is equal to infinity into log 1. Now log 1 is 0. So again you get 0 into infinity, which is a indeterminate form. So this is again, we can convert into this form only. Now next, 6th and 7th. For these two, you see this. Now two numbers are there, 0 and infinity, and there are 4 possibilities. Either you will do 0 power 0, or you do 0 power infinity, or you do infinity power 0, or you do infinity power infinity. But out of these 4, 2 of them are like determined. We can find its value, like we know its value. And other 2 are indeterminate. Now which 2 are indeterminate? 0 power 0 and infinity power 0. They are indeterminate. You can use the same y method. You take equal to y and take log both sides. But 0 power infinity and infinity power infinity are not indeterminate form. See, if you do 0 power infinity, it will be 0 only. 0 power 2, 0, 0 power 3, 0, 0 power any large number will be 0 only. And infinity power infinity will be infinity only. If I take a very large number and raise to some very large power, get a very large number. This is not indeterminate form. This is is a very large number. Indeterminate will be that we don't know the value, like 0 by 0. We don't know what it is. But if you get something as infinity, we just say it is infinity. The limit may not exist because for the value has to be finite. But we say we say infinity or we say undefined. Okay, undefined we use for infinity, and here we use indeterminate. Indeterminate means where we cannot determine the value. Undefined we use for infinity, where we say is a very large number, which cannot be defined. So remember, these are the 7 indeterminate forms. 0 power infinity, infinity power infinity are not indeterminate form. Okay, this will be important. We will see the next point. Now, how do we solve a limit problem? Always keep this thing in mind. Whenever a limit problem, say limit x tend to f of x is asked, first thing you will do is you put x as a here. You put x as a. Now there are two scenarios. First, f of a might be determinate. You might get the value f of a. For example, f of a will come out to be 4. Then the answer is 4 only. You don't have to solve anything there. Sometimes you get f of a as infinity. Then the answer is that only. We'll say answer is not like we'll say it is not defined, or we say undefined, or we say infinity. You don't solve anything. When do we solve? Only when it is an indeterminate form. If it is one of these 7, then only you have to solve a limit problem. Otherwise, you don't even have to solve. You just stop there. I hope it makes sense. I'll give you a few examples, guys. See, first one. Let us say they ask, like this, you just see here, you don't need to try this thing. I'll give you a few problems to try after this. This thing limit x tend to 1 x square minus 4x plus 5. What do you do? Just put x equal to 1, you get 2. That is the answer. Because it is a determinate. It is not determinate form. So we say when x approaches 1, this value will approaches 2. That's all. Nothing to solve here. Next, if I say limit x tend to 1, x square minus 4 over x minus 2. If you put x equal to 1, you get minus 3 over minus 1, which is 3. That's all. That is the answer. We do not solve anything here. Okay, now try this thing. Limit x tend to 1 sin x by x. Limit x tend to 1 sin x by x. What will be answer here? It will just be sine of 1. You put x as 1 here, you get sine 1 by 1, which is just sine of 1. So that is the answer. Next problem. Limit x tend to 3 x square minus 4x plus 3. Now, here if you put x as 3, we get 0 by 0. If you put x as 3, we get 0 by 0. This is the kind of problem which we'll have to solve. How do we solve? That we'll discuss in the next topic. For now, we're trying to differentiate when to solve and when to just leave it. So the first 3 problem, we leave it. That's the answer. But here we say it's a 0 by 0 form. So you'll have to solve this thing. Okay, how to solve we'll discuss later in the next concepts. Okay, now try this thing. Limit x tend to 1 positive 2 power minus of 2 power 1 by 1 minus x. Okay, see guys, what do you get here? The answer here will be 1. How do you get that? See, we have x tend to 1 positive. We just start from here. If x tend to 1 positive, we can say 1 over 1 minus x. So if it is 1 minus x, we can say this thing will be slightly less than 0. If x is slightly more than 1, this value will be slightly less than 0. And if you take like 1 by 0, it will be infinity. But if it is 0 negative, that means the value is 0 but from the negative side. So value will be minus infinity. So if it is 1 by 0, there also it will depend which infinity will be there, positive or negative. If slightly more than 0, positive infinity. And if it is slightly less than 0, it will be negative infinity. So in this case, it will be negative infinity. So this value comes out to be negative infinity. So now 2 power minus infinity will be what? We get 2 power minus infinity as 1 by 2 power infinity, which will be 1 by infinity. 2 power infinity will be infinity, no? So 1 by infinity will be 0. So you get 2 power minus of 0. So minus of 0 will be 0 only. So 2 power 0 will be 1. So the value answer here is 1. Okay, now try the next problem. Limit x tend to 1 negative 2 power minus of 2 power 1 by 1 minus x. Same problem. Now we're finding its LHL. Okay, now see. The answer here will be 0. How we get 0? Now we have 1 negative. So first of all, if you see this thing, we get limit x tend to 1 negative. If x is slightly less than 1, the value here will be 0 positive. 1 by 0 positive will be infinity. So we get 2 power minus of 2 power infinity. 2 power infinity will be infinity. So you get 2 power minus infinity, which we found out here was 0. So the answer here will be 0. Next one, guys. Seventh problem. Limit x tend to 0 negative x square minus 3x plus 2 by x cube minus 2x square. Okay, guys, let us start discussion. The answer here will be minus infinity. See how, if I just factorize this thing, get x minus 1, x minus 2 by x square into x minus 2. Now this x minus 2 will be like cancelled out. So what we get here, x minus 1 over x square. So you can see 1 is the only point which you have to plot on the wavy curve. Number line, you get 1, positive, negative. So when x is slightly less than 0, it will, so when x is 0, that means on the left of 1. On the left of 1, value is negative. And when I put x as 0 here, you get what? You get minus 1, which will be a finite number, divided by 0. So something by 0 will be infinity. And which infinity, where we can check by the Webiger method. On the left of 1, the value is always negative, so it will be negative infinity. The final answer here will be minus infinity. Okay, guys, next. Limit x tend to 0 negative sin x minus 2 over cos x minus 1. Try this problem. Okay, guys, let us start discussion now. The answer here is plus infinity. See how when x tend to 0 negative, you see sin x minus 2 will be negative only. When x tend to 0 negative, cos x minus 1 also will be 0 negative, because cos of 0 is 1. If you see the graph, cos of 0 is 1, but if you see on the right of 0 or left of 0, it will be slightly less than 1. So cos x we can say is 1 negative, slightly less than 1. So 1 negative minus 1 will be 0 negative. Okay, this 0 negative, 0 positive, we just understand these things. It will be very important. Many difficult, hard problems of JEE Advanced also we can solve directly. if you understand this plus minus this. So when x is slightly less than 0, cos x will be slightly less than 1, and slightly less than 1 minus 1 will be slightly less than 0. So what do we have here? Numerator is, now numerator will be negative, but some finite number, say around 2. Denominator is again negative on the left side, like slightly less than 0. So when you divide them, you get infinity, but negative by negative become positive. Okay, so you can say 2 by 0 is infinity, and both the terms are negative, negative, negative become positive. So final answer is plus infinity. Okay, next one. Now this is a very interesting problem. F of x is equal to x when x less than 0, 1 plus x square when x belongs to close 0 to open 1, and 2 minus x when x greater than equal to 1. Find first limit x tend to 2 f of x, second limit x tend to 1 f of x, third limit x tend to 2 f of fx. So you can try. Let us start discussion, guys. The first one, limit x tend to 2 f of x. You can see for x tend to 2, it lies here, and there is no change of function. We can directly say be just 2 minus x. So limit x tend to 2, 2 minus x, directly we can say will be 0. We discussed already. But when we say limit x tend to 1 f of x, now, see, they will never ask you to check LHL, RHL separately. That is up to you. You have to check. If they say limit x tend to 1 f of x, you have to find out limit we say exists only if LHL, RHL both are equal. So like in the first part, it did not matter because if I take 2 positive or 2 negative, function is same. It doesn't change. But in the second part, it will matter because 1 positive, 1 negative, the function will change. So we have to check LHL, RHL separately here. Okay, so you have to decide where to check, where to not check. Just to keep in mind, if you see the function changing in LHL, RHL, we have to check separately. But if you feel it is same, then we don't have to check. So in this case, a function is changing, so we have to check limit x tend to 1 positive f of x. So 1 positive, it will lie here. So limit x tend to 1 positive 2 minus x. So just put x as 1, you get 1. Now some of you might feel that if it is 1 positive, I'll put 2 minus 1 positive, you get 1 negative. Like if this is more than 1, so 2 minus 1 will be 1 negative. See, final answer, you don't need to write 1 positive, 1 negative. Final answer, we just say 1 only. Where it will matter if you have to put it somewhere else. Like if this value were to be used in some other function again, then 1 positive, 1 negative will matter. But the final answer always, we just write 1, 2, 0, infinity, whatever we get. We don't write positive, negative there on the final answer. Like you will not write the answer as 1 negative or 1 positive. We just write 1 only. Okay, 1 positive, 1 negative, use it if we have to put it somewhere else again. You will see in the next part. Limit x tend to 1 negative f of x. 1 negative means it will lie here. So if x is slightly less than 1, you lie here, just put x as 1, you get 2. So what do we see here? LHL, RHL are not equal because LHL is 2, RHL is 1. So we say limit does not exist. Next. The third part, limit x tend to 2 f of fx. Now this is the important one. Limit x tend to 2 f of fx. So here just put x as 2 positive. So you get f of 2 positive. Now what we see, what is the value of 2 positive? So if x is slightly more than 2, it will lie here. So if I put x as 2 positive here, so 2 minus 2 positive, can I say it will be 0 negative? So f of 2 positive is 0 negative. Now here we'll use 0 negative because we have to put this thing again inside a function. Where 0 positive, 0 negative, might make a difference. So here we'll have to put it as 0 negative. So now we see what is f of 0 negative. Again, we see the function. So f of 0 negative will lie here. If x is slightly less than 0, lie here. Now you put 0 negative, you get 0 negative. So final answer we just write as 0. So what do we get here? Final answer will be 0. I hope it makes sense. Let us see for 2 negative. Limit x tend to 2 negative f of fx. So put x as 2 negative, we get f of 2 negative. Now 2 negative again, slightly less than 2, but still lie here. If you put x as 2 negative, so 2 minus 2 negative will cancel 0 positive. So now we get f of 2 negative. So this f of 2 negative is 0 positive. F of 0 positive. 0 positive means it lie here because slightly more than 0. Now you put 0 here, you just get 1. So what do you get here? F of 0 positive is equal to 1. So the final thing here is 1. The final thing was 0. So you can see again RHL is 0, LHL is 1. So the limit does not exist. I hope it is clear, guys. This is an important problem. If you don't understand, just try it again. Otherwise, like I told you, can put in the comment section. I will try to help you, or you can ask me in the class also. Okay, guys. Last problem, I think here. 10th problem. F of x is mod x minus 4 by x minus 4. Limit x tend to 4. F of x they are asking. You can try it. Let's start discussion now. So here we have mod here. So again, if you have mod here for 4 positive, 4 negative, it will make a difference. No, because mod will open accordingly. So if I take 4 positive, the mod open with positive sign, you get x minus 4 over x minus 4, which can cancel out. See, when I say limit x tend to 4 positive, we can cancel out. Why? Because 0 by 0 we cannot cancel out. We cannot select 0 and 0, we cancel out and become 1. But when we say limit x tend to 4 positive, we say it is not exactly 0. It is a very, very small number, but not exactly 0. Any number except 0 we can cancel. So we make use of that and we cancel out this thing and we say the value is 1. I hope it makes sense, guys. This is an important point. So whenever we say limit x tend to 4 positive or 4 negative or even x tend to 4, there x is not exactly 4, it's very near to 4. So if it comes out to be 0 by 0, we can cancel here. And when x tend to 4 negative, the mod will open with negative sign. Again, you cancel out, but you get minus. So in this case also, you see limit does not exist. I hope it is clear, guys. Next. Now, next we have some theoretical points, not that important, but still just for the sake of completion, we just go through them quickly. If we have, say, limit x tend to a f of x is L, limit x tend to a g of x, some other function is say m, and L and m both exist. Then what do we have here? We say limit x tend to a, if you add or subtract them, if they ask you to find limit x tend to a on addition or subtraction of the function, what we can say is we can put limit on fx, that is L, limit on gx, m separately, and then add and subtract. This is allowed when the limit for the individual function exists. Okay, same we can do for if you multiply the functions. In this case, you get L into m. Same we do if we divide the functions. In that case, you get L by m, but their denominator should not be 0. Same we can do if you multiply fx with some constant k. K is some constant here. So in this case, just the limit will be k into L. Same we can do if it is limit x tend to a mod fx. In this case, we just become mod L. So basically, we can take limit inside the mod also. Same we can do if it is fx power gx, it will become L power m, but L square plus m square should not be equal to 0. I hope you understand what is the meaning of L square plus m square not equal to 0. When will L square plus m square equal to 0? When both L and m are 0. And what is the problem if that happens? It becomes 0 power 0, which is an indeterminate form. So we cannot use that there. Next, limit x tend to a f of gx. Now here limit x tend to a g of x is m. So we can say it is f of m, but there is a condition there. Only if f is continuous at x equal to m. Again, this point you will not understand right now because continuity and all we haven't discussed yet. So just write it down for the sake of completion of the concept. After we do the next chapter, continuity, then this thing will make sense. Next, now this eighth point is important. Now we are doing reverse. They say if limit x tend to a, fx into gx exists. It is given that there are two functions. If you multiply them and take the limit, it exists. What can we say about the individual functions? Will limit x tend to a fx and limit x tend to a gx, will they exist independently or not? So there are three possibilities. What are three possibilities? There is a possibility that both of them exist independently. There is a possibility that only one will exist. One will exist, other will not exist. And there is a possibility that both will not exist individually. If we do the limit individually on them, they will both not exist, even though the product of them exists. Let us see with the help of examples. First one, you see all three examples I'll give directly. You see limit x tend to 0, x into x. X into x will be x square. If I put limit x tend to 0, you get 0. So the product of the functions limit exist. Now will the individual exist? Yeah, individual will also exist. If I take limit x tend to 0, x, it will be 0 only. So here product exists, individual, both of them exist. Next, limit x tend to 0, x into 1 by x. If I do x into 1 by x, like I told you, it's 0 by 0 form, but x is not exactly 0, so we can cancel out. It become 1. So if you multiply them, limit exist. But will the individual limit exist? This will exist, it will be 0. But this value will be infinity. I told you limit exists only if the value is finite. So one exists, other doesn't. Third one, limit x tend to 1, step x into fraction x. Now this is an interesting one. If I take limit x tend to 1, step x into fraction x, you will see if I take 1 positive. At 1 positive, step x will be 1, but fraction x will be 0. So 1 into 0 will be 0. So if I take RHL, x tend to 1 positive, step x will be 1, fraction x will be 0, so 1 into 0 will be 0. And if I take 1 negative, then step x will be 0 and fraction x will be 1. So 0 into 1 again will be 0. So the product, if you do, the limit exists. But when you check them individually, step x, in one case will be 1, other case will be 0. So limit will not exist. Fraction x, in one case will be 0, other case will be 1, the limit will not exist. So you can see we have a case where the product of them exists, but individually they both do not exist. Okay, so this is an important point, guys. And the last one here, if limit x tend to a fx plus gx is given exists. So if it is given that the sum of two function, their limit exists. What are the possibilities here? Here we have only two possibilities. Either both exist or both doesn't exist. The third possibility is not here. Like it is not possible that one will exist and one will not exist. That is not possible here. Only both exist or both doesn't exist. What are the examples? Both exist. You can see an example like x plus x also. So I'll discuss the example where both doesn't exist. That is again the example where you do step x, fraction x. If I do limit x tend to 1, step x plus fraction x. You know step x plus fraction x is just x. So limit x tend to 1 of x will be 1. It will exist. But if you check them separately, they both do not exist. I hope it makes sense to all of you guys. the last point, limit n tends to infinity. This is limit n tends to infinity. Okay, this is n here, guys. Limit n tends to infinity x power n. If you ever come across a number which is raised to power infinity, there are three possibilities. Remember, if x belongs to -1 to 1, the value will be 0. Why? Because if you take as like a fractional number, say half, if you increase the power, the value will keep on decreasing. If I take half power 1 will be half power 2 will be 1 by 4, half power 4 will be 1 by 16. So if a number lie between -1 to 1, if you increase the power, the value will keep on decreasing. So at infinity will be almost 0. Right? All goes into approximate, like approximately 0, not exactly 0, approximately 0. But when we take limit, we'll just say 0 only. When x is exactly 1, it will be 1. Now, some of you might feel like it will be 1 power infinity. That 1 power infinity thing, guys, was when it will be like tending to 1. When 1 power infinity form we use, when this 1 is like approaching to 1, not exactly 1. We'll discuss this 1 power infinity thing in detail later on. But remember, if it is exactly 1 power, anything is 1 only. So here we'll say it is 1. So the indeterminate form we discussed 1 power infinity, there that 1 was approximately 1. You will understand with the help of this also. I'll explain you that thing here also. And third case, if x is more than 1, it will be infinity. See, if a number is more than 1, say 2, if you increase the power of 2, you see value will be increasing. And a very large number, the value will be very large, so it'll be like infinity. Now that 1 power infinity thing, guys, see, I told you that 1 power infinity, 1 is approaching 1, not exactly 1. That 1 could be approaching from left side or right side. If it is slightly less than 1, it is approaching 0. Slightly more than 1, it is infinity. So then when it's 1 power infinity and the value is tending to 1, the number could lie anywhere between 0 to infinity. Okay, again, it's all just a very high level concept. We don't need to go into that much of depth. So whatever points I have given, just remember them. With time, you will understand better. For now, just see this thing. If x lie between -1 to 1, where answer will be 0. If it is exactly 1, it will be 1. And if it is greater than 1, it will be infinity. This thing. That is the algebra of limits. So that is all for the first class. In the next class, we'll discuss how to solve the limits. So you can say this is all about introduction. What is limits? What is LHL? What is RHL? What are indeterminate forms? How do we see which problem is of indeterminate form and where it is indeterminate form? And then algebra of limits. So that we have covered in the first class. And the next class we'll start how do we solve the limits. There are different forms that all we'll discuss. Okay, guys, we'll continue in the next class. Bye bye.